Hi guys, I'm Rachel. I'm the president of Codeducation, and today we're doing a C++ workshop. And then at the end, we're going to do a little game. But also before that, we're going to have AJ over here talk about Disney because he works there as a software engineer, and he's also going to be teaching part of this workshop. And then he's also going to talk about an internship opportunity at the end. But before we start, I kind of want to introduce everybody for anyone new.
I'm Kathy. I am the vice president of Codeducation. I have been here since last year.
My name is Owen Van Lenten. I'm the secretary of Coded.
All right. Hi, my name is Mary Meeberg. I'm the social media editor of Coded this semester. What's up? Pretty graphics, huh? That's it.
Okay, so this is going to be our C++ workshop. First, I kind of want to gauge who has never, ever seen a program before in their life. Okay, well,
Okay, great.
this presentation is going to be a breeze for you then. We'll be able to post it for people who have never seen it before. So in that case, since everybody's already seen it, I'm not really going to go into a lot of detail, and then you guys will kind of be focused in on AJ's part, where he's going to do like more advanced programming.
Yeah, you can go ahead.
All right, C++ because it just makes sense. Here are just some examples of people that get to work in the industry when they know a program like C++: game programmer, software developer, software engineer, programming architect, and many more. And just out of curiosity, is anyone interested in these fields in this room? Okay, so like which ones?
Tell us.
Whoever wants to start. Software engineer, software development,
Game dev, but just for fun.
game, okay.
I'm technically already a software dev, game programmer, that would be better.
Okay, cool. Anyone else want to share? I want to make you share. I am interested in the first three. Okay, cool. So this would be for the beginners, but if you guys maybe want to use this one day because you feel like it, here is an online compiler that I was taught in my very first programming class that I ever took at FSU. If you guys have ever took Professor Vastola, she's Bob Meyer's wife. She showed me this. It's online GDP. You can program a bunch of different or compile a bunch of different languages on here. So here we have all the basics kind of laid out, where we have the skeleton of C++. I'm sure you've all seen a comment, the two different ways that you can write a comment. With the first line, we're going to have the include IOStream, which is a library. It tells the preprocessor to include the IOStream standard file. And if you're asking yourself, like, what is the IOStream standard file? In the C++ programming language, the input-output library refers to a family of class templates and supporting functions in the C++ standard library that implement stream-based input-output capabilities. This will make more sense once we get into the next few slides. Next, we'll have using namespace SCD, which in C++, just to know, every line, every statement is going to end with a semicolon. It's going to bug you so much when you're trying to write a program. I always forget the semicolon in lines, and I always get like an error. But so all the elements of the standard C++ library are declared within what is called a namespace. The namespace with the name SCD. We declare with this expression to let the compiler know that we'll be using these entities. I was told in a class recently that not every program uses namespace SCD because they might want to use their own versions of cout and cin.
Yeah, that's true. So you can actually create your own namespaces, just like they created the SCD namespace. So if you were, for example, making your own namespace and call it like my namespace, and then define your own cout function in the namespace. If you were to just call cout and you're using your namespace, it would instead use your version of cout rather than the standard cout, which by default C++ would typically go towards. But if you were to use your own namespace instead of SCD, then it would let you use your own version. In the case you're using both of them and you have two functions with the same name, first they'll throw an error when you're trying to write the function, but if somehow you get past that, and then you go to write it in the code, you'll then get a, I forget the name of the exception. There's an exception you get. Basically, it cannot differentiate between the two functions unless there's a specific overload of the function you're using. But that's pretty rare that you would write one that's like a specific. So yeah, just basically don't write functions that already are defined in the standard namespace if you're going to use both. Otherwise, if you are just going to use yours or theirs, then don't worry about it.
Awesome. So then we have the int main function that starts at line 4. This line corresponds to the beginning of the function, the definition of the main function. The main function is the point where all C++ programs start their execution. The instructions contained within the brackets after int main are always executed first when you run your program. And then here at the bottom, return 0 tells the compiler that this is the end of your program and exits. Are there any questions?
For
Okay.
C++, is return 0 necessary, or is it just a nice little thing to have?
I believe it's necessary.
Yeah, so it is necessary. If you don't put it, it won't necessarily break the program, but it will cause a lot of issues. It can cause memory leaks as well because your function will never actually end because technically like you didn't ever return anything. So the function might reach the end bracket, but you will still be using some memory because the VB compiler will leave an open space at the end of your program where like there would be typically code, which is a return statement, in which that's still being allocated out to the program even after you end the program.
It's just saying stop, but
Yeah, it's the same style. You can also use it like say you have something like where you're checking for an error, right? You can have something in there where so by default 0 means the program exited with no errors. If you use anything other than 0, then that means there's an error. So say for some reason you're taking some input from the user and then there's an exception that's caught from the input because it's not what you're expecting. They're expecting a number to get back like a string. In that case, you use like return 1 and then you would print out like an error to the console saying like use a number instead of a string.
Yeah.
So yeah, that's kind of what the purpose of return 0 is. If you use anything other than return 0, it's technically telling it an error. Yeah.
okay, cool. Yeah, I follow that.
I have a question.
Yes.
Instead of int main, like if we can put void, I think we not to use that return 0 or return.
So int main is the standard. If you've ever written Java before, it's the same thing as writing like public static or public static void main. Yeah, I think.
Convoluted public static.
Yeah, so it's int main is the standard C++. Void main is the standard in normal C, but int main is the standard C++.
Any other questions for our team? Just for reference, I took one C++ class.
It would work. It's just int main is the standard.
So here we have the basics. This was just written to show you the purpose of end line. It's just a new line. It's the equivalent of just hitting enter on your keyboard. So I just kind of did like a super simple example of how you can see it just helps you make it look just a bit nicer, just a bit cleaner. So cout is used to the output display data to the screen. It is always followed by, I guess you would call it the less than signs or append to indicate that cout is taking the input that follows and outputs it to the screen. End line, as I kind of briefed earlier, is the new line character. This is equivalent to pressing enter on your keyboard in a text box. Again, just as I said prior, you can see in this example how it's kind of used. So we have variable types and declarations. Integer, which is whole numbers, string, text and sentences, float and double, which the difference between float and double is the size of the number. So, but they can include numbers with a decimal point, Boolean, true or false, and character or char for individual characters. And on the side, I included how to properly declare them and define them. You'll see the variable type, the variable name, and what it holds. Quick kind of graph that I made, variables in use, just like kind of easy. You could see it's on the way down. The declaration, initialized, its use, and what its output is going to be. You can see it in an example for integer, string, and char. Then we have simple control structures such as if, else, and loops. If the condition is true, then this will happen. Else, this will happen instead. So it'll just exit the program. Thank you, Mary, for this. If for a while, you can see an example of while loop kind of down below here. Condition is true, then this will happen until the stop condition is met. Different types of loops can do different things. Yes.
What is
Cout. So
You didn't cover it. Wait.
cout is,
Oh, okay. Yeah, I was right there. Got it.
it's okay. It's used to output the display. Like cin would take in your information and cout would put it out.
All right, so pointers are essentially a way to point at a variable that already exists in memory. So to put that in layman's terms, say you have a variable A that holds the number 10, right? A has an address on the block of a disk drive. That's a memory address. It's a hex value. It's in the format of like 0x and a bunch of random letters and numbers based off of the address. So essentially a pointer is a pointer to that point in memory. In C++, the way you do it is you would have variable, say Mary is a variable we have it declared. And then we're trying to declare a pointer to Mary called Rachel. Essentially, you would declare, say Mary was an integer, you would do int star Rachel equals and Mary. So the star operator on any variable type, it says it's a pointer, and you can do that with even variable or even like types that you make. So the pointer operator applies to all variables that exist, even ones that you make. So here, Rachel will hold the address of Mary in this case. So if Mary's address is 0x and then a bunch of ones, then Rachel's address will also be 0x and a bunch of ones. So what that means then is that if you were to reassign a variable that as a pointer, that will also reassign the original variable as well. So if you change, say Mary held 10 originally, right? If you change Rachel to be 10, Rachel will be 10, and now Mary will also be 10, because you're not just creating a copy of Mary like you would be if you did like int Rachel equals Mary and not the and Mary. Instead, you're using that exact same instance of Mary, in which case you are then reassigning Mary effectively. Right here, like I said, basically saying what I just said, the variable is established by the operating system during runtime. But for hypothetical, you can say the memory address is 1880. In this case, we have Rachel equal to 21, Kathy is equal to Rachel, which means that Kathy is equal to 21, but not equal to the address of Rachel. And then we have Mary is equal to the address of Rachel, in which case the Kathy is assigned 21, but then Mary is assigned 1880. You are able to reassign the actual value in that address, like I just said. You have to use a little bit different syntax for that. But you are able to reassign that value. But if you were to just see out Rachel and then Kathy and then Mary, you would get 21, 21, and then 1880 in the console. So that's what you'd kind of see. It might look weird. So if you ever see some weird hex number, just know you probably need to dereference the pointer using the star operator. And the way you do that is you would have, so if you were to see out Mary here, you would just do see out and then put the star before Mary and then do whatever else you want to put on the end of it. Okay, yeah, so right here. So see, this will print out the value that's in IP here rather than just printing out the address of IP. Yeah, so like I said here, we have a pointer, we can access the value stored in the variable which it points to. So in this case, we have X and then IP is a pointer of type int. So we say IP is equal to the address of X, and then we say X equals, then obviously print out the value of X, which is going to 27. And then IP will then print out the address of X, which is 0x and a bunch of stuff. And then the value of star IP will then print out 27. So now we're on to classes. Was I still supposed to be talking about this?
Yes.
Okay. Okay, so I'm not sure what this extra bracket's doing here, but anyways, so we're getting into classes now. So classes are kind of like the foundation of object-oriented programming, which is C++ is an object-oriented language, and so is Java, and there's a few other ones out there. C# is another instance of that. So basically, you're going to have classes here. So in this case, we're defining a type of C rectangle or a class of C rectangle, which then can be used down here, as you can see. But so basically C rectangle here, in classes, you have a couple different levels of protection is what it's called. So you have public, and then there's protected, and then there's also private. We only use public here, but I'll show those when we go into the demo. But yeah, so essentially here, we have a class. So going back to what I was saying before, by default, all parts of a class that are not defined in a certain level of protection. So like right here, we have public, and then there's an indentation. Everything that's inside of this indentation right here is declared as public. By default, though, everything's public anyway. So actually, everything in this class is just public. So we have X and Y. And then, actually, am I wrong there? Is that private? Is that, what is this? So I guess it is private by default. So private.
Anything that isn't declared, I'm pretty sure automatically becomes private.
Okay, well then I apologize. So it actually is by default private. So these X and Y are private. And then we have a function declared here called set values. And then we have a function here called area, which is just returning the value of X and Y. So we have two different definitions here. As you can see, we have one that's a not inline definition. So this is where we have, this is what you kind of put in the header file right here, is something like this. That's just kind of, it's called prototyping, when you just do this, where you give a return type and then the name of the function, and then also the types of parameters it takes in. And then below that, we have the same thing, but we have a return type, and this function takes no parameters, but then it returns the value of the private member data as X and Y. And then right here, we're going to be setting them, which I'm showing right here. So down here, we have this C rectangle set values. So this double colon is the syntax for defining methods that are inside of classes, or implementing methods inside of classes. So as you can see here, we have the name of the class, and then a double colon, and the name of the function you're trying to implement. And then these parameter types here, and also the return type, and also this name, have to exactly match what's in your header file or class definition. Because if they don't, the compiler will throw an error saying, I don't know what this function is, like this doesn't exist in class C rectangle. but the name, you don't have to put names in these definitions either. We didn't here. And then down here, we're defining names. It really doesn't matter. You could put names there and put different names down here. It does not matter. But so anyways, we're setting the values here. We take an A and an B, and then we just set X to be A and Y to be B. And that is assigning the private member data variables of this. If they were to be public, we could just do like instance.x equals this, and then instance.y equals that if they were public, but they're not. So we have to do this function. And then on here, we're going to instantiate some classes here. So C rectangle, and then we have rect and rect B. And then we can just go ahead and set their values right here. And then we're getting out the area, which then we get, I guess, 12 and then 30. So yeah, so that's essentially how that works. And yeah, so one other thing you probably want to add in this that we'll show in the demos, you want to have a constructor in here, because instantiating classes like this can cause memory issues. Sometimes certain compilers will throw errors if you try to do that. So it's just a matter of which compiler you use, but to be safe, I would always create a constructor and then just call the constructor when you're instantiating a new object. We have a question here. Oh, you're talking about right here? So yeah, so the reason why you wouldn't use X is for, so pointers aren't specifically for, typically you don't use them for things like this. You can, but the number one thing you use pointers for is when you're passing in objects into functions. You pass them by what's called reference instead of value. So when you pass things into a function like we did right here, this is called passing by value, in which case we're just passing straight up the number 3 into here. And that works fine for primitive types because there's not much going on in them. But for more complex types, like a class that you make, you can't, passing the whole class into a function can cause issues. So instead what you want to do is you pass a pointer to the class, and then you can then dereference that pointer, and you have the whole object available to you rather than passing in the object itself. Sometimes you get issues where if you pass in an object, it'll pass in a reference to the top level version of the object, and you won't get all the data inside of the object because it won't perform what's called a deep copy. And you would do that by creating a copy constructor for the object, but to avoid having to do that, you can just pass in a pointer. And when you do that, then it will automatically pass in the exact object you were working with before. But it should be noted though, if you are to do that, then it will modify the object you're working with as well, if you're using an object like that in a function.
Okay, so these are just like little, you can kind of talk about them, but they're just like little things that can like help you learn C++. I know AJ is a huge fan of Udemy for like learning various topics.
Yeah.
So we just threw on some like training stuff that can like help you actually like learn how to program in C++. This was just kind of an overview of like some basic concepts. I mean, obviously, if you want to know the language very well, you will have to do a lot of extra practice. But these are just some links. We're going to provide these slides in the Discord and in the group channel.
This is all the files we made so far. We made actor, actor.hpp, main, makefile, movie.h, and movie.hpp. I'll give you guys a second to catch up if you guys are following along on the Zoom. Is anybody following along, or are you just watching? So no pressure then, right? All right. Anyway, so we'll open up the makefile again. So we have this main.cpp dependency in here, and then we need to add in actor.h, actor.hpp, and then movie.h and movie.hpp. Yeah, also for the record, I'm doing it in a text in like a terminal just for simplicity to keep it in one window. You can do this in a text editor, you can do this in an IDE, whatever you want to do. IDE is typically a little easier because they'll build this for you. You don't have to do this part, but it's really not all that hard.
C-line is a good one. I know
Yep.
uses that.
So you're going to run this command here. G++ is the GDB compiler. It's built into your most Linux operating systems. It doesn't come with Windows by default. So you have to go through a process of downloading it and then adding it to your path, which you can Google that. It's pretty easy, but you should follow like a guide online for that. And then we'll make it. So this .o flag here on G++ tells us to put the output file in this file. So we're going to call our output main.exe, and then we're going to say it to compile main.cpp. Yep, exe. The extension does not matter. It just makes a binary file. So it really doesn't matter whatsoever. And then go ahead and save that. And now if you look at our makefile, you'll see that's all we have in there. So next we'll go over to actor. So in here, we're going to make a class we're going to include IOStream real quick, and then we're going to use the namespace SCD as well, just for simplicity. And then we're going to, let me move this out of the way. All right, so, and then we're gonna have a class actor. Capitalization doesn't matter. The standard, I think, in C++ is all lowercase, but I'm gonna do it Java style, just because I can. So in actor, we're gonna have a public get information, or what it'll be string, or or we'll do actor first. So their first thing, we're gonna have a string that's gonna be their name. Let's go through and define a class first. Then come back to that. So we'll have a private in the actor, we'll have a private string name, string date of birth, and string, we'll call it int age. Okay, and then we're gonna take a string, and int. So that's gonna be our constructor for actor.
Oh, question.
Why do you need names for the parameters in the constructor?
Because this is just the header file, so we don't need names for it right here. Once we go into the implementation, then we have to provide it names, otherwise we won't be able to reference them. Does that make sense?
Yeah.
Okay, cool. So yeah, we'll have that constructor, so we have to make an actor like that, and then we'll have a function that returns a string. We'll call it get information, and that won't take any parameters. Okay. So let's go ahead, and that should be good for that one, I believe. So we can go ahead and save that, and then we'll go over to actor.hpp. And then we'll go ahead and implement this. So we got to include, actually, sorry, I missed one thing on the last one. We do have to down here at the very bottom of this file, if it will let me, thank you. We have to include actor.hp, or not, sorry. So when you're doing classes that exist as C++, in C++, like the standard library class is what they're called, you use this bracket notation to import them. Otherwise, you use this notation right here with the double quotes around it. And you'll see more of that as we go through it. So down here now, now that we're importing this at the bottom of this file, that means actor is already defined as a class. So then what we can do through here and do in this file is we can literally just write straight up code into the file. So we're going to include, okay, I really can't type, stream, and then we're going to use the namespace, and then we'll do actor, and we had actor like this. So the string name, string date of birth, and int age. And then we come back here, and then we do name equals, or actually, so you can't have the same names here, they need to be different. So we just make it N, we'll make it D, and then we'll make it A. And so we have name N, and then we have DOB equals D, and then age equals A. And then we have actor get, or sorry, this needs, the constructors don't have any return type, but then for other functions, you need to have return types on here. So string actor get information is what we called it. And then we'll just do, this will return name, and then we're going to do name, and then we do a new line here, and then we do date of birth, and then we do DOB, and then we do let's see here, what was the last one? It was H. And we do that, and then you put another new line here real quick, and then plus H. And then we'll throw another new line in the end so it doesn't check anything out. And actually, that's fine. Okay, cool. So that's our entire actor implementation. So that is done. And then we go over into movie now. So we're going to have include IO stream, and then we're going to do namespace here. And then we're going to have class movie. And then we're going to do private real quick and define that out. So in private, we'll have string title, int release year, and then we'll have a actor star actors. So that's a pointer because that's going to be an array of actors. So we're going to have to kind of go through that and define how many actors we're going to have as we go through it. But yeah, so it typically when you're dealing with arrays as well as like complex types, you use pointers to handle arrays because it makes it easier to pass them through functions. So now we're going to go into the constructor here. So we're going to have movie, and then we're going to have string int and actor star, and then we're going to have do get information again, and that will take no parameters. That will return a string. So now we're going to go over to movie.hpp. Actually, I forgot the last part of the last one again. So here we're going to include and this doesn't need a semicolon either. I'll throw it on there for safety, but it doesn't need one. I just don't want to deal with it not working.
I love one-time breaks.
Yeah, obviously. There we go. Shot saved properly. Cool. All right, so now we're gonna give them movie.hpp. And then in here we're gonna insert.
There was a time. for it. I really would like that. Like, it's like one of the first songs that I ever played. It's so bad. No, but he purposely did it to us. And we were all like, what? All right, AJ, continue. Where are you?
And then lastly, we're gonna have the actors, which we'll build that up in a second here. So let me just do this actually. Okay. So that looks weird, but it'll be fine. So essentially what we have here, and then we're gonna add on actor string. Okay, so we're building out the movie class the same way, or the movie implementation the same way we built out the actor one. Not very different there. The only thing we're gonna do specially here now is we have a list of actors now. Actually, one more thing I need to throw in here is the number of actors. And then go build that in the class real quick. So in here, we're gonna have up here, I need to add an int. So one thing that base C++ arrays are kind of done with is the keeping counts of itself. They only keep a count if you define them to have a certain count. Otherwise, the count is just the maximum size of the array, which can be anything. So if you have an array that can take 5 elements and you only have 2 in there, the size will still be 5. So that's something you have to kind of watch out for. So typically you just pass around counts of how many elements are in the array. So every time you add something to an array, you do that. For this time, we're just gonna make kind of simple, but yeah, so that's why I have this dumb actors here. So we're gonna have int I is equal to 0. And then we're gonna do, I forgot an I, int I equals 0, and then I is less than num actors, and then I plus plus. And is everybody here familiar with for loop like syntax and have they seen that before? Okay, cool. So then this is easy. So then now we're just gonna add on to the actor string here. We're gonna do, this is gonna be the star. I forget exactly what the syntax was I used for this. I'm pretty sure it's just actors, and then it's I, and then it's this. I'm pretty sure it's just this get information. That should work, I believe. If it doesn't, we'll come back and fix that. But so essentially what this will do is, and I forget if we added a, just in case, I forget if we added an extra new line on there. So this will come through and then append all of our actor information to this actor string here, which will then print out at the end here of everything. So this will make a nice little string notation for all of our actors that'll be spaced out properly with all the information about them. And then, yeah, so that should be it for that. So now we can come over into our main.cpp and then write it out. So here we're going to include IO stream. And then we're going to include, so when you're including files, you just only have to include the header file because the header file includes the implementation below it. So in this case, we're going to include movie.h, and then we're going to include then actor.h. And actually that needs to come before movie. So move that down real quick. So now we're going to have int main, just like we saw before. And then we'll throw this in there, return 0. and then we're gonna have actor. So we're gonna have actors equals. Then we're gonna use what's called an initializer list here. So this is basically you can create an array and then automatically throw all the elements into it as well as you go. So we're gonna have actor, and this will be so I forgot what our constructor was off the top of my head. Let me go back and look at it real quick. Okay, so it's string in. So it's gonna be name, date of birth, and age. Cool. So we can do that real quick. So the name is going to be we'll go ahead and do and then his date of birth, we'll say it was June 4th of 1970. I'm not sure how old he is. Sorry if he's not that old. And then that would make him what, 70? Not 70. I can't do math. He'd make him 51. April 4th, 1965. That's pretty close. 50. He's 56 years old. That what I just said. What about Rachel? Who's the Thor actor again? Who's the Thor actor again? You said it the other day. Chris Hemsworth. Okay, and then what's Chris Hemsworth's date of birth, Mary? Fill me in. 38? Okay, so now we have an array of actors with 2 actors in it. Then we're gonna go ahead and construct a new movie here. So we'll call it movie. And then we're gonna say movie. So this is how you can construct a new movie here. So you're gonna have, it is title, I believe was the thing. So we'll call it Avengers Endgame. I don't know when this movie came out, but that was a release. That was the release you were asking for. When did this movie come out? I'm a horrible Disney employee. 2019. Okay. So here we're kind of doing what we were talking about earlier. So we're passing in. So we have our constructor here for movie. Let me double check that this is 100% correct, just because I don't have it pulled up right now. So it's string and you guys also put in the number of actors. That's right. So let me do that real quick. There's gonna be 2. Yeah. Well, obviously there's a lot more than 2 actors, but for the sake of time, I'm not gonna put all of them in here. But anyways. So we're passing in the address of actors here because, like I said before, with the pointers, actors is an array and is also an array of complex objects at that. So to preserve all of the data in there, we're just going to pass in a pointer to the array of actors that we've created. And then down here, we should just be able to see out movie.get information. And if all goes well, this should just work. So let's give it a try, see what happens. Oh, okay. No matching constructor for initializer of movies. Okay, I think it's just, I'm pretty sure it's just right here. I think it's not the address. I'm pretty sure it did that automatically does that when you have arrays. Let's try it again. No.
4 warnings, 6 errors.
Did I capitalize string? Where did I do that?
Yeah, you did.
I did indeed. Yeah.
It's not case sensitive.
It is case sensitive for the names of types, yes. And that was in what, movie.hpp? Yeah. All right, undeclared identifier age. Oh, I need to put a semicolon here, and then no semicolon here, I think is what I was complaining about. A lot more than 3 warnings, it feels like. Yeah, extra, those are just warnings though.
Ignore the warnings. It's just
Use of undeclared identifier age. No, I just typed in movie, or I typed in age here. That wasn't a thing. This is not age, it's release here. Okay, so we cannot concatenate a string or that's fine. So what we can do then is this. So we go vim, and then we're going to do main or movie.hpp. So we're going to use what's called a static cast, since that's actually correct. You cannot append numbers into strings technically. So you have to do what's called a static cast. So you do this, and then you do string, and then you just do this, and that should create a working version of this. Okay. So we're going to fix this the easy way. So we're going to do all this complex stuff. We're going to just make this a string.
I mean, it's a release here. I mean,
Yeah, it can be a
it
string.
can definitely be a string.
Like I said, my C++ is a little rusty, so please don't judge me. I don't write this for work, so.
Maybe this. Is that like a team debugging session?
Oh, we're down to nothing, just about. Oh, okay, we should make that a, I'll use Nano for this time for you.
Only correct way.
Warning and 2 errors generated. We're having the same thing here. We do actor.h. It's just I have it in age. So it's a bit of string as well. What? Oh yeah, you're right. It's like JavaScript in that way. JavaScript is the same way. So this is going to be string here. I just try to save it like it was the Nano because I was thinking about Nano. We're getting closer. Oh, I just need to go change these again. It's just because right here, when I'm creating actors, I'm passing in their ages as numbers. Just need to wrap as strings. Compiled. Okay, so now we can do ./main.exe, and there we go. So we have our movie here, and then we have the title is Avengers Endgame, and then we have the release year of 2019, and then we have our actors of Robert Downey Jr., his date of birth, and then his age, and same thing with Chris Hemsworth, date of birth and age. So yeah. After some debugging, we got it working. Actually, I'll fix that last warning too, so we can see it compiling with no errors. You guys can feel how good that feels. Yeah. So this is just because I have semicolons here. I'm going to make it. Boom, no errors whatsoever.